ATP is extremely important in all walks of life as it provides the energy for the body, allowing us to keep moving and contracting muscles. It can be created in three different ways, for example PC stores, the lactic acid system and the aerobic system. These systems are needed to prolong the use of ATP as it initially lasts a very small duration of 3 seconds. The energy from the singular ATP is created through the splitting of one of the P's from the molecule, which releases energy as the bonds are very strong and powerful, and is therefore an exothermic reaction, and is then left as ADP, adenosine diphosphate. This can be seen during the sliding filament theory, as ATP is needed to produce the power stroke, as this gives the energy for the muscle to contract and do that. Due to the ATP becoming ADP once releasing energy, the other systems are vital in resynthesizing the ATP through endothermic reactions to allow it to break off once again and provide energy. As there is 3 different systems, the one used to resynthesize the ATP highly depends on the intensity and duration of the activity you are completing. For example, ATP, due to only lasting 3 seconds, can only be used alone during sports like shot put, where a very rapid burst of energy is needed. However, in an event such as the 100 meters, the PC system could be used as a combination of ATP and the PC stores, and that would last around 10 seconds. The anaerobic/lactic acid system is utilized in a slightly longer event like the 400 meters, for example, and initially the aerobic system is key during a long-lasting event, e.g. a marathon, as it can last a very long time, constantly creating and resynthesizing ATP. However, it is also the slowest of the 3, but it does create 34 ATP each time. The first system that can be used to resynthesize ATP is the PC system, phosphocreatine system. This system uses PC that's stored in the muscles to attach the ATP back together to allow it to create energy for the muscles. Out of the 3 systems, this is the quickest and will provide the body with the most power. However, is often not used due to the combination of the initial ATP and the added PC only lasting a duration of 10 seconds, which is still not very long. It begins when the PC is broken down due to the enzyme creatine kinase releasing energy from its bond, and also the P that can be added onto the remaining ADP, which is left over from the initial bond break. As energy has been created, this can be used to produce an endothermic reaction, which allows the P to create a strong bond with the ADP to form ATP, which can then be split up again, producing a rapid burst of energy for the muscles to contract. This can be seen in the diagram above. Once this has been completed, if exercise is continued, another system will be used, as the PC needs around 2 minutes to replenish. After around 10 seconds of exercise, the PC system will have fatigued, so the glycolytic system will need to be used in order to sustain energy for activity. This is a much longer process than the PC system, as it involves the breakdown of more substances through enzymes, however produces ATP and lasts a longer duration. A key disadvantage of this system is the lactic acid produced at the end, which fatigues the muscle and is a byproduct of the creation of ATP. It initially begins with glycogen, which is stored and converted into glucose through the enzyme glycogen phosphorylase, and this glucose is further broken down by phosphostructure kinase to produce pyruvate acid. During this, 2 ATP are used for glycolysis, creating 4 ATP molecules, and therefore a net gain of 2 ATP molecules. If oxygen was present, the pyruvate acid would continue to be broken down into the Krebs cycle. However, as this system is anaerobic, the system is forced to stop there, and as a result lactic acid is created, which is bad for the muscles. One of the biggest advantages of this system is the duration, as it is much longer lasting than the PC system or AT by itself. However, it is still not quite as long lasting as the aerobic system. At 3 stages in the multi-stage fitness test, we also measured our blood lactate levels to test for the volume of lactic acid measured in mmol. As the graph suggests, in the rest stage of this test, before the running had begun, there was an extremely low level of lactic acid at 2 mmol. This is likely because the body is either using just singular ATP or the ATP-PC system, which lactic acid is not a byproduct from and is therefore not produced. However, this changes in the second measurement, as after level 4 of the multi-stage fitness test, the lactate dramatically rises to 16. This is likely slightly continuous exercise that is being undergone, and therefore the ATP-PC system is unable to be used, as it only lasts a short duration. So now the glycolytic system has become more dominant. This is an obvious reason for the high increase in lactic acid, as it is a byproduct of this system and is produced as part of it. The last measurement was taken after the test had finished, and there was a slight increase, which may be due to the body switching to the aerobic system, in which lactic acid is not a part of. Throughout the majority of long-lasting sports, such as rugby or football, it is likely all three systems are used at different points in the game. For example, in football there are many scenarios where a quick burst of energy would be highly important in retaining possession or winning the ball, and in this case the player could just use their initial ATP to carry it out. This could be seen in a header or a tackle, as they last no longer than 3 seconds, as they are an explosive movement, and therefore will not require additional energy. However, during a sprint to perhaps reach the ball or catch a player, we will require the PC system to create more ATP or resynthesize more ATP, and therefore give us more energy. This would allow us to still have the fairly short burst of energy, around 10 seconds, that we would need to carry out the run. However, would not be used after due to its still fairly short duration time, similarly to the initial ATP, as it does not resynthesize the ATP quick enough. It is also likely that a central midfielder would be using the aerobic system throughout the majority of the game, as they are tasked with constantly running from either ends of the pitch during attacking and defending. This means they need an extremely high amount of ATP to be resynthesized to be able to create the energy they need during a game, and is the reason this system is used, as it creates 34 ATP after moving through the electron transport chain. It is likely most players will work in the glycogen system of energy interplay, as their movements will often last longer than 10 seconds, however not long enough for the aerobic system to kick in. This is because during a football match there are many rest periods, depending on where the play is and the position you play, so the body can regenerate.